Okay, welcome students. So in this class I'm going to talk about how to solve the degenerate problems. How to solve the degenerate problems. That's what we are going to discuss today. So this comes in transportation problem. Usually in the transportation problem the number of allocations must to be less than m plus n minus 1, where m equals the number of rows and n equals the number of columns. If this condition satisfies, then degenerate problem occurs. That's what we have to understand here. So if a degenerate problem exists, then we cannot get the solution. So we have to change this degenerate problem into a generate problem. In a simple way it is possible to do that. So I will take one example. Now look at this. This is a problem given to us. Okay. We have to do this problem by modish method, because optimal solution we have to get. For that, NWCR to be used to get the initial basic solutions. So we have to use NWCR northwest corner rule to get initial basic solution. Afterwards we have to go for modish method. Now let us see whether this problem is a degenerate type or not. Now look at that. We have done that particular problem by NWCR methods and we are getting these solutions. Okay, we are getting these solutions set. So 2 units are transported from here to here, 2 units are transported from here to here, 1 unit is transported from here to there, and 5 units transported from here to there. So how many allocations? 1, 2, 3, 4 allocations only. 1, 2, 3, 4. But let us calculate this. If you calculate this, n denotes the number of rows and n denotes number of columns. Here row 1, row 2, row 3. So m equals 3. N denotes number of columns, number 1, 2, 3, so 3 columns are there. 3 plus 3 minus 1 equals 5. But what is the number of allocations? The number of allocations equals 4, but this value m plus n minus 1 equals 5. What we see, number of allocations is less than m plus 1 minus 1. Therefore the problem given is a degenerate solutions. Okay, so how can we change this? I will do that now. Now this is a way we can change a degenerate problem into generate problem. Now take the given matrix structure here. In that matrix structure, which are the very lowest transportation cost cell? The cell which contains very least transportation cost we have to take into account. In this particular matrix given, this is a very lowest transportation cost, very lowest transportation cost, very lowest transportation cost. Am I correct? So what we do there, we are assigning a very small element, epsilon, or infinitesimal, means very small, minute elements, epsilon, we are assigning. We can assign here, or we can assign here, we can assign here. Where can we assign? We can assign at the least transportation cost cell, any places, here or here or here. If we do so, then this degenerate solution becomes a generate solution, and then we can go for the modish method. Okay, so this is the way we can transform the degenerate problem into a generate problem. So just we are assigning a very minute variable at the very least transportation cost cell in the given matrix. Here of course 3 cells with the very least transportation costs are there. Am I correct? But some matrix will have only one least transportation cost. There we have to assign this very small element, infinitesimal element we have to assign. Okay, so this is the way we can change the degenerate solution into a generate solution. Then we can go for Modi's method. So thank you very much.